Hello, I'd like to share with you some observations about critical chain project management in PERT. It just so happens there's some characteristics of PERT analysis that align rather well with critical chain project management, or CCPM. Let me show you what I'm talking about. First of all, here is a paper I wrote together with Dr. Tracy Richardson a few years ago. It's called Using PERT Analysis with Critical Chain Extensions to Facilitate Information Systems Project Schedule Decision Making. The reason it says information systems is because this was done on a sample case using an information systems project, but it could be any project. So let's get started with PERT analysis and just remind you how this works. The PERT formula, I call it, there's different ways of labeling the most likely, the optimistic, the pessimistic. You could call it best case, worst case, most likely. But the formula is the same. You take the optimistic, the 4 times the most likely, and the pessimistic, and you divide it by 6. This is known as the beta distribution. It's a special distribution that weights the most likely outcome a bit more heavily while still incorporating the worst case and the best case. This is a way to figure in uncertainty in your activity duration estimate. So what does this have to do with critical chain? Let's take a look. It doesn't have anything specifically to do with critical chain, but there is some interesting quirk of the critical chain requirement that aligns rather well with PERT. Notice on the right that in critical chain project management, you've been asked to, instead of estimating each individual project activity at the 90+% level, you should estimate that at a 50% level. Well, lo and behold, if you look to the left here, the PERT analysis, when you do this weighted average estimate using the beta distribution, what you arrive at is a mean. And the probability of achieving a mean is 50% because it falls right in the center of the curve. So I conclude that when you conduct PERT analysis and you estimate each activity using the PERT 3-point estimates, and you calculate that weighted average according to the beta distribution, what you end up with is a 50% activity probability time. And that's exactly what critical chain asks you to do. So I'm thinking, hey, if you're going to do PERT analysis, maybe you can incorporate some aspects of critical chain project management, since each activity is inherently estimated at the 50% level when you use PERT. So let's just take an example of how you might approach this. Here's a case in this paper that shows a simple computer installation schedule with only 12 activities. You have your activities, your activity identifiers, your predecessors. That makes sense. Once you have your activities and predecessors, you can create a network diagram. Okay, this doesn't have durations. This just has the activities and predecessors in place. Okay, I think we're all familiar with this. The next is you would conduct 3-point estimates. You see this up at the left-hand corner, 3-point estimates for each activity. That's optimistic, pessimistic, most likely. And then you use the PERT formula, optimistic plus 4 times most likely plus pessimistic divided by 6. And I just call this a weighted average estimate. It is kind of a weighted average. It uses the beta distribution, but this is the weighted average estimate of each duration. Okay, and this is classic PERT analysis. Okay, let me move this out of the way. Once we have done this PERT analysis for each activity, you can now calculate the project standard deviation by taking the square root of the sum of the variances of every activity on the critical path. So what you see here is the identification of critical path activities. You see the variance calculation, classic PERT analysis, where you take a pessimistic minus optimistic divided by 6 squared. You add that up and you have the project variance. You take the square root of that, and that's the project standard deviation. You could ask, why do you need to do that? Recall that PERT analysis is not just about doing a 3-point average. You're doing this so you can have the project mean, which is the 50% probability time of achieving that schedule, but also the standard deviation. And if you have the mean and the standard deviation, you can convert standard deviation to units of time to calculate what would be a 95% probability schedule, which is it's a better schedule to plan for than a 50% probability schedule, as you can imagine. So here's the PERT activities on the critical path in bold, the calculations for the activity variance. I calculated that the estimated duration, which would be the project mean, is 46 days. Project standard deviation is 2.81 days. So if I wanted a 95% schedule, I would need to add 1.6 standard deviations to the 46 days, which I would need to effectively add 1.6 times 2.81 days, which is roughly 5 days. So 46 becomes 51 days if I want to make a 95% probability schedule. If you're familiar with PERT, you follow me so far. This makes sense. But one thing that PERT doesn't answer specifically is if you are going to take a 50% schedule to a 95% schedule, where do you put those extra days? Well, if you step back to critical chain project management and note that we have something in common with the 50% duration for each activity, what would critical chain tell us to do with those extra days that go beyond the 50% probability? Critical chain would tell us to use those as buffers. So one thing you could look at is take that 4.64 days and just create a project buffer at the end, of a buffer of 4.64 days. Or you could break that up. This is rather small, so it may not be the best way to do it. You could put some feeder buffers into your schedule to make up, or a combination of both. So the idea is you run your PERT analysis. Once you've done that, you've got a 50% duration, a probability for each duration. You've got a 50% probability for the overall schedule. You calculate what you need to arrive at a 95% probability. And having done so, you now have a project buffer. You can use that as a project buffer using critical chain methodology, or you can also use portions of that for feeder buffers. So I see this as a way, taking the characteristics of PERT and CCPM and melding them together to have a nice methodology. It gives you some additional guidance of what to do with those extra days when you seek to achieve a 95% project schedule. I hope you found this useful.